All right, welcome back. Let's implement our breadth first search. So I'm going to go over, and the very first thing is I'm going to define a method. We could call it BFS or breadth first search. It really doesn't matter. I'm going to do BFS just because it's really annoying to type. And it doesn't need to take any arguments. We're just trying to visit every single node. Okay. And right off the bat, we need two things. First, we need our data, which is what we'll return at the end. So I'll just make an empty array. We have a couple other variables, so I'll just declare them all together. We have our queue, which will also be an empty array. And we can just start with that. And the first thing that we'll do is place the root node in the queue. Okay, so that's easy enough. Queue.push this.root. So that puts, if this is the tree we're working with, that puts 10 in there. And then we're just going to loop as long as there's anything in the queue. We're going to take dequeue from the queue. So let's just start with that loop while there's anything in the queue. So if we just did while queue in JavaScript, if we have an empty array and we negate it, this tells us that we get false, which means that an empty array is truthy. So that's not what we want. It's not like an empty string, or some languages, an empty array is falsy because it's empty. Not the case. So what we're going to do instead is while queue.length. So 0 is falsy, as we can see there. Or doubly, we could get back to false. Anyway, if that didn't make any sense, I'm sorry if I did a bad job explaining that, but we can't just say while queue. We need to say while queue.length. So while there is something in the queue, we're going to remove something from the beginning of that queue. So I'm going to do queue.shift, and let's put this in a variable. But rather than inside this loop continuing to make a new variable over and over and over and redeclare it, let's actually go up here and make another variable just called node. And let's start it as, why don't we actually do this? This.root, like this. Okay, this is just me being sort of ridiculous, but I like all of this to line up. Okay, let's just do that. It really doesn't matter. You could just do 3 different vars. Anyway, we have node start as this.root. Then we can just do push node. It doesn't really matter. But now I don't have to do this var node equals and just have this var keyword in a loop. It's not a good idea. So I'm just going to now assign node to be queue.shift. Now, of course, I could have just started node as nothing. Could have just made it undefined or null. But this works fine for me. So we take from the beginning of the queue. So if we're pushing at the end, we're going to shift from the beginning in order to get that first in, first out. Then we need to take that node and add it to the list that we're going to return. Then we check if there's a left. We add that to the queue. We enqueue it. If there's a right, we add that to the queue as well. So we did node equals queue.shift. Now we're going to do data.push node. So that's adding into our list that we're going to return. So if this is our queue, empty, and this is our data, empty, the very first thing that happened is that we pushed, sorry about that siren if you could hear that, queue.push 10, given this tree. Then while queue.length, node equals, take this out and add it into our data. Now we're going to check if there's a left. If node.left, then we'll do a queue.push node.left. And we'll do the same thing if there's a right. And so we add that in to that queue. And that's actually it for our loop. Then at the end, we just need to return this data variable where we're building up everything we've visited. So just to reiterate that, if we take 10 from the beginning, which was in our queue, we add it to data, then we're going to check, is there a left for 10? Well, given our structure, yes, it's 6. So we add 6 in. Then we do node.right. Is there a node.right? Yes, it's 15. So queue.push 15. And then the loop starts over. There's still a length to the queue. So now node is equal to 6. So we take 6 out and we push it on to data, which is what we visited, and we return at the end. And then we check if there's a left. There is. So we add that in, which is 3. And we do the same thing with the right. We add that in, which is 8. And we keep going. And I did this in the last video, so I won't step through every single moment. But let's just see if it works. If it does work, we expect to get this. So I'll copy this over. This is what we want. Let's try running it. So down here, I have the code to actually build the tree. And now I'm going to do a tree.bfs. Oh, yeah, that's annoying. Maybe I should just push the value in to make this easier to see what's happening. So let's do push node.value. It really doesn't matter, but just to make this easier to see. Okay, so we got 10, 6, 15, 3, 8, 20. And we're supposed to get 10, 6, 15, 3, 8, 20. That's our breadth first. All the way across, all the way across, all the way across. So horizontal before we go vertical. Breadth before depth. So that's BFS. It's relatively straightforward if you take advantage of a queue. Remember, first in, first out, just a list of things that we need to visit. We're keeping track of it, and it grows, and it doesn't really matter. Yes, this is hard-coded for left and right, but if this was a ternary tree, we could add, first, second, and third child. Or we could do it dynamically and have a loop and loop over all the children. So it doesn't have to be a binary tree. It's the same basic principle. You use a queue. All right, so that's BFS.